Welcome, everyone. My name is Victoria with Redmond Mag and Visual Studio Magazine, and I'd like to thank you all for joining us. The topic of today's webcast is MARA, the Journey to OpenTelemetry, sponsored by Sumo Logic and NGINX. Before we begin, I just want to cover a few housekeeping details. We will have a Q&A session at the end of today's event, so if you have any questions, please make sure to type those in the Q&A box. Our sponsors have also provided some resources which do correspond with today's event, so please take a moment to check those out. They're going to be located to the right of your audience console. Today's webcast is also being recorded, so please keep an eye out for a link in your email to rewatch the presentation or to share it with a colleague. You should receive that email within 24 hours of today's event. And now I'd like to introduce you to our speakers. Today, we have the pleasure of hearing from Jason Schmidt, Solutions Architect at NGINX, and Melissa Sussman, Lead Technical Advocate at Sumo Logic. So we're in for a great event, and with that, I'll pass the time over to Jason and Melissa to get us started.
Hello, everybody. I'm going to get us started here, and then I'll be handing off to Melissa to dive deeper into some topics. But we're here today to talk about MARA. MARA is a project that we've been working on for almost 2 years, and I'm pretty excited to talk to everybody about it. And as we get into this, let's start with, well, what is MARA? About 2 years ago, we were asked to design a modern application, or what a modern application should look like. And it became pretty clear to us as we all started talking in our group that the application was only one part of the overall modern application experience. And we started using the analogy of an iceberg, where we have the application on top, but underneath it we have things like monitoring, management, observability. Somewhere there's Kubernetes running. Somewhere even below that there's hardware. But so focusing in just on the application is not the right thing. We have to look at this as a whole unit. So the elevator pitch for MARA became an example architecture using Kubernetes that aims to be as production ready as possible. Now that we talked about what MARA is, the next question that comes up is always, why did you guys go and do this? And the number one reason was we have the experience. My team at NGINX, the Community Alliances team, we have a fairly deep tech team in terms of our experience. We have operators, developers, QA people, product managers, project managers. People have done all these roles within large and small organizations before they came to us. So with that experience, we wanted to put it to use and build something that we'd be proud of. The second thing we wanted to do is respond to some of the anti-patterns we see out there. And those are things like demos that you start working on that never actually seem to work except for on the person who's showing the demo's computer. Things like marketing materials that are masquerading as tech demos, or things where you have to go through and buy a bunch of licenses in order to make something work. And then finally, we wanted to highlight open source software as a core part of modern applications. And this goes to something that we've talked about a lot and my team is very passionate about, and that is preferring protocols over products. If we build on open protocols, then we can change the products out. So it may be as your organization grows, you have different needs, and you don't want to be locked into the products you picked when you did not have these needs. You want to be able to grow as your product grows or grow as your environment grows. So how do you use MARA? We've tried to make this as simple as possible. You clone the repository, and then you have credentials for a cloud or a local Kubernetes installation. There's a setup script that builds off everything we need to install. And then you run a startup script that's going to ask you some questions. Things like, how big are the nodes? What are your passwords? Where do you want to send your telemetry data? Once you've done that, you're up and running MARA. So depending on your back end, you can have MARA running anywhere between 10 to 40 minutes, depending on your choices, depending on your cloud. So how should you use MARA? Well, you can clone it and run the whole project. And a lot of people do just that. You run the project, and that's great. But more importantly for us are the next two use cases. Review a pattern used for something. Look and see how we instrumented our application for OpenTelemetry. Look and see how we've done logging, or how we're sending metrics, or even how we're standing up Kubernetes. Look at that pattern and see if it makes sense to you. And then, if it does, take that code and use it to solve a problem in your environment. I will add that Mara is a complete application, but it is not intended to be production ready. It's production ready, but it's not intended to be put into production. So don't just run this out there and think, okay, I've solved my problem. It is going to require a little bit of work to secure and make sure that it works for your use case. So who runs Mara? What people are out there actually running Mara? Well, developers use it as a way to stand up their application. You'll see in the demo later, we have a fork of the Google Bank of Anthos called Bank of Sirius that we use as our application, but you can take that out and put your own in. As an operator, this next use case is near and dear to my heart. How do I manage, monitor, deploy, and support an application? And more importantly, how does it break? If I overload my application, what tells me that it's overloaded? What do I do if my cluster can't handle load? How do I auto-scale? QA engineers like to use it because they get a fresh, clean, reproducible test bed each time. They stand up Mara, they do their tests, they tear Mara down, they stand it up again. So it's a nice way to get a good baseline as you're doing testing. And kind of what we're going to talk about today, vendors and projects. So if I have a project for something that I want to deploy in Kubernetes, I can go and take Mara and plug my own project in. So today, our demo is going to show us taking out the observability we have in place, which is Elastic, FileBeat, Kibana, Grafana, and Prometheus, and replacing it with Sumo Logic. And that kind of speaks to the strength of Mara. Mara is designed to be pluggable. Mara is designed to be modular, so you can take out the parts you don't want, put in the parts you do want, and make it run. And for that, we tell you, fork it. If you think the community would be interested, put in a pull request, and we'll add it to Mara. Mara is intended to be plug and play. So observability. We're here with Sumo Logic, one of the leaders in the field of observability. So let's talk a bit about observability and how that impacts the Mara project. At its heart, observability is a data problem. I'm guessing that most of the people on this call have gone through this exercise before. Is there a problem? Where is the problem? Why is the problem happening? And depending on the tooling you have, these may take anywhere from seconds to minutes to days to weeks, which is why we say the more observable a system is, the quicker we can understand why it's acting up and fix it. So as we went through and built Mara, we kept running into people questioning observability. So that became a point in Mara that we were very, very cognizant of. And also, as you're going to find out when Melissa talks, we have the OpenTelemetry project coming along where we're moving towards a standard way of getting observability data through. So where we started, again, we have an application, it's the Bank of Sirius. We forked it from the Google Bank of Anthos, and that project uses Google's CloudTrace and a number of other Google services. So our challenge first was to fork it, was to de-Google it and take away all the dependencies on Google Cloud, add management and monitoring on top of it. And our telemetry challenges were to take out the Google-specific code and then figure out how we wanted to instrument the application, how we wanted to test traces, and yeah, how to get metrics, how to get logs from it. So from that starting point, we've come to this particular view of Mara's observability. So for tracing, we've gone ahead and put the OpenTelemetry collector out into the Mara deployment, and we've used the OTel SDK in the Bank of Sirius. So if you go into our Bank of Sirius and look, you can see how we trace it. Developers out there, go ahead and look at the pull request, and you can see the process of taking this out and putting it back in. For logging, we're using the Elastic Stack. For metrics, we're using Prometheus. And for visualization, we're using Grafana and Jaeger. And data storage for all of these are at the individual components level. So We have logging data in Elastic. We have metrics data sitting over in Prometheus. We have data being sent to Jaeger, so it's all over the place. So how do we move to the next incarnation of metrics in Mara? Well, we came up with some considerations. We don't want to be locked in. We want to be able to switch between observability technologies. I think, again, everybody here has been at a shop where 20 years ago somebody made a decision, and now we're all living with it because it's load-bearing and nobody has the time or the budget to switch it out. With the avoidance of lock-in, we want it to be easy to use. So reduction in friction for implementation. I don't want to burden my apps team with doing a lot of extra work, one, because it's extra work, and two, because they'll probably tell me to go away. So I want to make it easy to put in. And if I can automate it, so much the better. And then visualization tooling. If you're collecting data, that's great, but we need to do something with it. And I want a technology that enables me to take seemingly disparate pieces of information and combine them together to tell me what's happening in my system. And that means correlating a trace with a log, with a set of metrics, so I have something actionable that I can go and do something about to fix a problem. And then on top of this, we get to the cost part. How many resources am I dedicating to telemetry? This is going to take CPU, it's going to take memory, it's going to take disk. How much of this do I keep? How long? And what's it going to cost? And with that, I'm going to turn you over to Melissa to talk about telemetry collection.
Hi, everyone. Talking about telemetry. So we'll just go into the slides. Here we have a visual representation on why unified collection matters. We were talking about basically what happens if teams are collecting data, without full observability into what everyone else in the system gets to see. And here, all these people are wearing blindfolds, but they're all touching an elephant, and each of them thinks it's something else. Someone thinks it's a wall, someone thinks it's a spear, someone thinks it's a snake, someone thinks it's a tree. Unless you basically have really good data fidelity, you're not going to be able to know that it's an elephant. And it's sort of a good analog for the IT ops world where, ideally infrastructure engineers should not need to enact application changes due to sending data to disparate backends, right? But once a disparate system becomes larger, specifically when people have these highly federated models and people are not only using modern applications and running a bunch of different containers, but they need to run Kubernetes or, Docker or something similar, then, standardization around telemetry becomes really important as you collect all of that data. And I was going to talk a little bit more about pipelines. So there's a lot of different kinds of data that can come through a given pipeline. But essentially telemetry pipelines sort of route that data in the form of logs, metrics, and traces from where it's generated to a corresponding backend. Transparency around that data collection is really vital. So we know, obviously Jason had mentioned, having vendor neutral formats is really important for the data collection process. So with that sort of in mind, we can start talking about also OpenTelemetry. Obviously you have things like data can also intersect with the way in which it is routed, specifically how it's expressed via monitoring. So you can have Kubernetes container information, region information, geo-IP information, and other logging and trace data in there. It became really important to look at OpenTelemetry as a standardization from the Cloud Native Computing Foundation. It's sort of aimed at first to unify receivers in a telemetry pipeline. But over time, it's sort of become more than just the receiver. It's become a standard for collection that really aims to be vendor agnostic. So it essentially allows for, for example, trace data and different formats to basically be unified through a variety of, specifically a variety of different projects, including Open Census from Google and then Open Tracing. And it sort of captures all of that data through a single telemetry pipeline. And on the right, we see an example of what is in a telemetry pipeline. So we have a receiver, which basically takes in that data at the start of the telemetry pipeline. It can be in the form of logs, metrics, traces. You have a buffer, which I put in gray because It sort of holds the data for a short period of time until the processors or exporters are ready to take in that data. But it can happen in the processor or in the exporter, or both. And you'll often see things like chain, where it's like buffer, processor, exporter, buffer, processor, exporter. And so like this is just a very simple example. And then the processor analyzes or transforms that data from the buffer. And then, of course, the exporter is the end of the telemetry pipeline, and that's where the data gets exported into its corresponding backends in said pipeline. So we'll go into talking a little bit more about disparate backends. So why would you need to have disparate backends for data collection? Well, many app developers, SREs, DevOps practitioners, security analysts, et cetera, have to work around compliance and data protection. So a good example would be things like COPPA. So when dealing with information that could be personally identifiable, especially in the case of children, we have to think about, well, how does this relate to OTel? You might have to have a disparate backend for like where you actually store that data versus where you actually store, let's say, an in-game data when you're doing video games. And it becomes really, if you do that a lot and you don't have like a unified telemetry collection system, it becomes impossible to approximate system-wide health across all of these disparate backends. So additionally, you have to think about things like user IP addresses, API keys, passwords, et cetera. And when you are thinking about, like, let's say, even GDPR compliance and FedMAP requirements, you might not be able to, you have to kind of think about all of the disparate tracing that has to happen in order to route to those separate backends. So, yeah. And here we have a commentary about the wonderful thing about standards is that there are so many of them to choose from Grace Murray Hopper. And of course, we're going to talk about the challenges for data collection, particularly without the use of a common vendor-agnostic open standard. So I had talked a little earlier about the origins of OTel, but I wanted to go into the history a little more and what sort of the differences were between open tracing and open census. And here we see an XKCD comic sort of lightheartedly poking fun at the increasing number of standards in an attempt to unify what is available, only to, in the end, have a competing standard. So on the left, though, we see that open census and open tracing projects, I think each originated from Google, actually. Those projects shared the common goal of data unification, and then they merged in 2019 and sort of went under that CNCF governance. Then that became OpenTelemetry, which is then backed by a bunch of different major vendors and has an incubating status within the CNCF. So here we have them sort of like fighting it out, but me, who knows that they're both OTel at the end of the day. Foundation work is really important to help prevent that problem that was identified by the XKCD comic and by Grace Hopper. We don't want multiple competing standards. And I know, older projects are already sort of being brought into OTel, and that is now what everybody is trying to use. So to go into a little bit more, I wanted to contextualize the open source concepts that are explored in the prior slides. So here we see sort of a hodgepodge of vendor-provided collection, instrumentation, and backends. So that's what data collection looks like without using the OTel standard. When we were talking about how it's really important to have vendor neutrality, this is what it looks like when there is no vendor neutrality, essentially. Everything is vendor provided. So all the logging libraries, log collection agents. So for example, you might be using FluentBit, you might be using Jaeger, you might be using a metrics agent like the old open census agent. And all of those would have their own disparate libraries, their own agents, their own APIs. It will really get very complicated when you are trying to monitor all of that. And this diagram should give you anxiety, honestly, because you're generating all this data, logs, spans, and metrics as an output. And all of this goes into separate backends as well. And the instrumentation layer is tightly coupled to that program code. So it can, like, you might have to handle things manually. Some things might be automatically, some things might be semi-automatically. And the solutions that were available just a couple of years ago like you would basically need to have a separate library for handling each of these signals, which aside from it being just a lot of work, I mean, if you have one person who really knew that, really understood your infrastructure, and they were like the head architect, and they leave your company or something, there's going to be a lot of people who might not know, you know, how all of this sort of disparate APIs work together. They might not necessarily have a familiarity with all of the disparate libraries as well. And you'd have a variety of different agents and collectors. So you would generally want to keep a small footprint on the instrumentation library. So the collector basically comes in really handy with providing all sorts of like processing capabilities, buffering, handling connections to the backend. And it sort of provides that enrichment capability, which then attaches the metadata about the origin of the data back to that backend. And it helps you navigate sort of all the signals, you know, that include things about, like, again, the instance ID, the Kubernetes pod, that, you know, the custom tags that might be in there, et cetera. So this one is about sort of the promise of observability 2.0. So on the right-hand side, you'll see the OpenTelemetry collection and how that sort of how that differs from like the disparate collection process where you have separate collection. And I know a unified methodology right now, you know, for collection is a bit of a unicorn, but we are so well on our way at this point. A lot of vendors are starting to provide like an OTLP and a single agent collector. So we actually sort of have a lot of folks moving over from that 1.0 concept to the collection 2.0 concept. As you recall, you know, a lot of this stuff, you know, you have separate libraries and agents for each of the signals on the left. And that is just not the case when you're using OpenTelemetry, where pretty much anything except the back end is streamlined and provided by the initiative. And even things in the back end, honestly, like we're starting to see a lot of progress on, you know, the open source front in terms of upstream contributions back to OpenTelemetry. That just sort of not only helps people have a unified collection agent, but also sort of like helps standardize around tracing and different libraries and such. So ideally, though, you want to move to the place where you have a single agent / collector, which allows you to plug in a bunch of different external data sources and then correlate the signals. And that sort of includes with it a rich set of processors and exporters that actually align with open standards and will be used by multiple vendors. So in that way, it remains vendor agnostic. And yeah, this slide, again, is just about why OpenTelemetry kind of matters. Again, it just allows users to build and own their own collection strategies without vendor lock-in. It also puts the focus on analytics and not so much on the team just putting all their time and resources into collection. It also, at the moment, is at the core to Sumo Logic strategy, not only from a collection standpoint, but we actually have been doing a lot of upstream contributions as well to the project. And yeah, this is how to contribute specifically. Well, this is to OTel or Mara, but I guess the links and such are more for OTel. If you don't know where to start and you want to contribute, there's actually, like, within any open source project, there's a help wanted or good first issue screenshot example of where you can start. And that would be for the OpenTelemetry Java projects. Frequently, though, it's enough to just sort of like leave a note that you would like to start working on a given issue. And if the scope of work is huge, it's good to split it up into several different PRs. Specific instructions are available in each repo, and you can basically look at the example of contributing.md so that you can start doing that if you want. And you'll need some kind of like contributor license agreement for your first commit before it gets accepted. But it's a pretty simple process, and it's pretty well documented if anybody wants to do that. And with that, I can hand this back to Mara plus OTel.
Thanks, Melissa. I kind of wrote along on the last slide, so I didn't have to include the Mara specific one. But just like the OpenTelemetry project, raise an issue. If you want to work on Mara, talk to us. If you want to tell us we did something wrong, tell us we did something wrong. We can talk about our decisions. the open source community is very welcoming on both fronts. So it'd be great to have you. But now that we've talked about that, and we've talked about what Sumo Logic has done, and we've talked a bit about OpenTelemetry, let's talk about how that applies back to Mara. So as we were going through and building out Mara and working on what we thought was the best thing to do, we decided that OpenTelemetry was the way to go. So step one was to integrate OpenTelemetry tracing into Mara, and right now that's in the Bank of Sirius. We're looking at extending it to other components. The next step is to convert metrics to use OTel, to convert our logs over to OTel, and then finally to operationalize OTel and make this all work for us. And at this point, I want to put in a plug for the OpenTelemetry collector. If you go to the OTel project and take a look at it, there is a collector that is like the Swiss Army knife to end all Swiss Army knives of formats. It'll ingest all sorts of different formats. It will do processing. It'll export different formats. And for me, that's kind of the core to the OpenTelemetry promise, is being able to convert things into this OTLP, this OpenTelemetry line protocol, that we can then pass around so we don't have data stuck over here and data stuck over there, and nobody knows who's actually using this data anymore. So I view OpenTelemetry, and especially the OpenTelemetry collector, as the light at the end of the tunnel of a lot of pain that I had as an operator trying to manage all of my data for observability. So what's the future look like for Mara? Well, in the golden future time we're envisioning, everything is going to be OTel. It's going to all be OTel, and then you pick the visualization layer. You're a big enterprise, you need the features that Sumo offers, then go use Sumo. If you want to try something else, try that. We want to enable you to pick what you want to use to view your data and not be constrained by, oh, it's in this proprietary format, or I need this specific collector. We want it to be open, and again, I say it a lot, it's the protocols over products. I want to use an open protocol so I don't have to get locked into a certain vendor. So what are our challenges? These are the challenges we're facing, the maturity of some of the components. Some of the components are still in beta, but I can tell you that they've come a long way, even in the small amount of time that we've been working with the OpenTelemetry project. It is moving fairly fast. We're early in the life cycle of other components. So when we went through and instrumented the Bank of Sirius, there are things that have come out since then that would probably make it easier now. So it's kind of being at the early end of the adoption curve. There are going to be some teething, there's some teething pain, some hiccups there. And then we're looking at operational concerns. What are our resource concerns? What CPU memory? Is this going to cause a performance impact? And then what we always come back to is what about my data storage? What about my long-term data storage? Now, I can tell you that just doing my testing with Mara for this demo, being able to pull out the Elastic Stack and put Sumo in has significantly reduced the footprint of what we're running. And part of that is because we're sending the data to Sumo SAS, but another part of that is due to the lightness of the collectors we're using versus what we were using before. And then on top of all this, standards and best practices. As this is all kind of newish technology, we're creating some standards and best practices as we move forward with it. So we're kind of doing a lot of, hey, what are you doing over there? And trying to model those practices with Mara. And being open to, again, being wrong. One of the key advantages to working on a project like Mara is being able to be wrong very publicly, and then show how we handle it and show how we step back from it and show, most importantly, how we learn from it. So Mara and OpenTelemetry, we can sum everything I've been saying up to using this OpenTelemetry as a standard. It makes it easy to swap out observability technologies. And ease of change is an overall goal of Mara. So if you're looking at Mara, we've chosen Pulumi as our infrastructure as code provider, and you say to me, well, I don't like Pulumi, but I have a lot of Terraform experience. We're okay with a fork that brings Terraform in, and we'll merge it back into the main line, and then we'd have 2 components there for users to pick from. So we want you to be able to swap things out. And the other thing that's important is, my group really is very bullish on open source. We like to use open source wherever possible. However, we've all worked in large enterprises, and there are certain things that you can get from a commercial offering that you can't currently get from open source if you don't have domain-specific expertise. So we want Mara to be able to show off a hybrid where I have some open source, I have some commercial components, and it all combines to get my work done, which at the end of the day is what we're trying to do. Now we're going to go, there's going to be a video that plays in a minute here that kind of takes you through what it looks like deploying Mara. We're going to deploy Mara on DigitalOcean, and we're going to deploy Sumo Logic as part of that. And we're just going to click through now. The video has all been shortened down. It doesn't really run that fast, but I didn't think anybody wanted to watch the screen slowly update for 20 minutes. But here's the big difference between adding Sumo Logic to Mara. We are taking out a couple projects, and we're adding one in. It is really quite simple. Pulumi allows us to modularize things, so we have Elastic in the log store component. We have our file beat and log agent. So the actual work that I took to make Sumo come up and running with Mara was about an hour and a half, and a large part of that was figuring out how best to tell the main application to use different components. So Mara is, again, intended to be easy to modularly break apart. And with that, I'm going to ask our producer to go ahead and roll the video.
Hi, my name is Jason Schmidt. I'm a solutions architect with NGINX and one of the core maintainers of the Mara project. The Mara project is our modern applications reference architecture. This is an application that's been designed from the ground up to be easily deployed, in this case via Pulumi, and to use modular components to show what a modern application could look like if we focus on protocols over products. Today we're going to be doing just that by removing the existing observability and replacing it with Sumo Logic. So first, we're going to hop out to nginx.com/Mara, which is going to put us right into the repository. There's a lot of information here, so if you don't know about the project, it's a good place to start. We have chosen Pulumi as our infrastructure as code provider, and we're embedding that in Python. So right now we're taking a look. You can see those are some of the DigitalOcean related projects out there that stand up our environment. Let's look at some of the Kubernetes components, and we can see the existing observability. Switching over to the Sumo branch, we see we now have Sumo Logic there. And I want to show you how easy this is to do. This one Python file using the Pulumi SDK stands up Sumo Logic for us. It's basically a wrapper around the Helm chart, but it allows us to embed some logic in there. If you're following along at home, there is a Sumo file in the main directory. You're going to want to read through this because certain things have changed for this preview. At some point in time, those will be merged in and become part of the main documentation, but until then, you want to look at this, or your mileage may vary when you actually sit down and try to deploy it. So let's deploy it. The first thing we do is we check out a repository, making sure to get our submodules, and then we're going to go ahead and switch to the Sumo Logic branch. Once this is done, it's time to build our virtual environment. Since we do run with Python, we need to make sure we have all the necessary SDK and other modules installed, and we also want to make sure that we have the right versions of utilities. So you will notice, in addition to installing Python dependencies, you will see the script going through and pulling down things like kubectl, Pulumi, and the DigitalOcean command line tool. Anytime you work on Mara outside of these scripts, it's advised you activate the virtual environment so you're always using the correct versions of tools. Once the virtual environment is built, we set a variable called sumo equals true to our environment, and we make sure we have our Pulumi and DigitalOcean tokens set. From then, it's time to actually start bringing up Mara by finishing the configuration. You will be asked a number of questions in this part about your deployment. I'm not going to go into depth on them because of this video length, but everything here is documented in the repository, and you can see what it's used for. I will add that in most cases, it is okay to use the defaults. For things like your Sumo logic, cluster name, access ID, and key, you'll need to get the latter two of those from the Sumo website, and you'll need to come up with the first one yourself. And then you'll be asked a number of password questions. These are passwords that are used internally that you probably won't need to use at any point in time, but we do ask them because they are passwords. And then you're going to want to leave the test user and password Bank of Sirius site login at the values they are for now. Once this is all done, we start building things. And you'll notice we go ahead and tell you what we're doing, and we provide output on each step. The goal is if there is a failure, we tell you about it. Also, I want to point out that this is running at about 20 times speed. A full stand-up of Kubernetes with Mara on DigitalOcean takes somewhere in the neighborhood of 20 minutes. But for the purposes of this video, we have shortened the sequences quite a lot. Anyways, you'll see it go through, you'll see it deploy Sumo logic, and the final thing we deploy is our Bank of Sirius application, which is a fork of Google's Bank of Anthos. Once things are deployed, we want to take a quick look and make sure things are the way we want them to be. And if you haven't used it, the K9S utility is my favorite way to do this. It's curses-based, and you can go through and easily see what's going on. So here we see all the bits in the Sumo logic namespace, and we can go ahead and take a look at the logs. We can do things like get a description. You can even edit the YAML within K9S. It's a lot easier for me than remembering a lot of the kubectl commands. So we're up. Let's take a look at our application. So we're going to go log in. We're going to use that test user and password. And from here, we have an application running. We can scroll around. We can send payments. We can deposit funds. It is a functional application. It is worth, if you're interested, taking a look at the Google Bank of Anthos, which we forked it from, or our specific Bank of Sirius repository to see the changes we've made, because we've done a lot of work to add OpenTelemetry into this application. The Google version uses Google's CloudWatch, and we're using OTel. So you can see how we put that in. Now, we do include a load generator, so another thing that K9S lets us do is to forward a port. So we're going to go to the load generator in the Bank of Sirius. We're going to do a port forward. And now that we have that port forwarded, we're going to bring up the locus load generator, and we're going to go ahead and run some testing so we can see data in Sumo logic. Locus is very simple. I want 50 users, spawn them one a second, and I give it our endpoint there. Then locus kicks off and starts spawning. You can see our failure rate, you can see transactions per second. If, like me, you like to see things break, you can crank this number up and watch things fall apart. So we're near the end of the demo. We have Sumo logic deployed as we said we would, and we're passing data up to Sumo logic, and we're taking a look at it now. And this screen right here, I think, really speaks to the promise of OpenTelemetry. If you look, we're getting information that's coming from tracing, that's coming from metrics, that's coming from logging. I'm looking at my service overview. I can then flip over and look and see what CPU utilization is like. I can go through and pull logging out of one of the pods and see what's happening and correlate things. In the original Mara, using Elasticsearch, using Grafana, using Prometheus, using Jaeger, I'd have to look in multiple tools and then correlate this information myself. But because we're sending this data up via OpenTelemetry, vendors that sit on top of it can concentrate on doing things like we're seeing here, can concentrate on presenting it, can concentrate on figuring out ways to enrich the data to make it better. And also, OpenTelemetry provides somebody who's writing an agent, somebody who's writing something that's going to send logs or metrics, or somebody who's writing an application. It's a blueprint to send data out where they know it's going to be able to fit into most systems because it's OpenTelemetry. And this is why, with the Mara project and with my group in general, we like to concentrate on protocols over products. We want open protocols so that we can concentrate less on how we get the data there and more on what we do with it. And then I'm going to kind of go to one thing that I really love about Sumo Logic and why I wish I had it years ago. It's the hygiene check here. This is super simple. Do I need to look at something? Is it fine, or is there a problem? Am I overpaying? And again, this is pulling data from multiple sources, running it through some logic, and giving me actionable information that I can do something about. And that's great to me. So if you made it this long, I want to thank you for your attention. And if anything here is of interest to you, please go to nginx.com/Mara, go to our repository, star us, do a pull request, fork us, raise issues. If you think something's great, tell us. If you think it's not great, tell us. We're happy to hear from you. We created Mara for the community. Thank you.
Awesome. Thank you so much, Jason, for that demo, and thank you both Melissa and Jason for that presentation. It does look like we have some questions in from our audience members, and just a quick reminder for those watching live right now, if you have any questions, please make sure to type those in the Q&A chat, and we'll make sure to get them answered for you. So the first question that we have, I think this is touched on a little bit, but I'll go ahead and ask it. It's, how can I contribute to Mara?
I can take that one. You know, we keep I keep talking about contributions because, you know, this is a community project, and you're currently looking at about 40% of the Mara team right here in this seat. So we'd love to have other people to join us on this journey. And all you really need to do is to go to nginx.com/Mara. It'll put you right into the repository. And from there, you can raise an issue, raise a pull request, even something as simple as saying, raising an issue and saying, I wish you guys supported X. Like, I wish you guys supported a different technology than you've picked here. That's fine. We'll have the conversation. And if you have the skills, you know, like if you're an expert at one of these other technologies and want to join in, we're happy to have you. There are some pretty simple, like easy, low-hanging fruit issues. If you're new to the open source community and you want a nice starter project with a small number of people to deal with, you can come to Mara. And then on top of that, I do want to again say, you know, you can contribute to Mara, but also please look at the OpenTelemetry project. I was at OpenTelemetry Days last year. It was one of the most fun conferences I've been to. It is a really great group of people working on it, and that's where I actually had a lot of talks with Sumo people there about the direction Mara was taking. So nginx.com/Mara, and if you go to the OpenTelemetry project, they'll be happy to take your contributions as well.
Wonderful. Thank you, Jason, for that answer. The next question that we've received is, why did you choose Pulumi as your IaaS provider?
That's a great question. We actually get asked this one a lot, and this is when we started this project, we obviously were drawing on our experience, and everybody on the team had different levels of experience with different technologies. And at the time, we had some former colleagues who worked for Pulumi, and they pitched Pulumi to us. And Pulumi was great in that it allowed us to write in Python. It allowed us to do things that we could use the language to do. So if you look at the code, a lot of the code is actually figuring things out and then passing it on to the Pulumi SDK to go do things on our behalf. So that was a big thing. The other big thing was, since we knew we were going to be working with Kubernetes, we wanted to have as much ability to use the different deployment methods. So within the Mara code, you can see us using Helm charts through the Pulumi provider, which is how we're deploying Sumo out there. You can see us using YAML manifests, which is how Bank of Sirius is deployed. And there's a couple places where we're making native calls to Kubernetes through the Pulumi SDK. So that was a big plus. And then kind of the killer feature at that time was Pulumi can ingest Terraform providers. So if there's a Terraform provider for something, it's automatically a Pulumi provider as well. So those were all big positives. And then the ability to write in different languages. We've done this in Python. but they also support TypeScript and Go and JavaScript. So you can kind of write your own language. They keep the APIs consistent with the SDKs. So those are all very positive things that Pulumi has brought to us. On the negative side, we have a lot of questions about Terraform. Why don't you guys use Terraform? And this is where we kind of turn around and say, we'd love to have a Terraform version. Can you help us write it? Because again, it's a small project. We do, F5 NGINX does pay for us to work on this, but there's only a few of us doing it. So we are completely open to other IaaS technologies. We would just need help to get them off the ground.
Perfect. The next question that I have in here is, why did you choose the components that you did?
And wait, who's that question for? For Jason, right? I assume.
I believe so.
I think we can both answer that question. Melissa, do you want to answer the question from you, or do you want me to take it?
Well, so for the demo, I guess you can answer it for the demo, and then I'll go back and answer it for Sumo later.
Okay. So for Mara, it was basically what have we used before? That was kind of our baseline, and then what did we want to try and use? And so we had a lot of experience with the Elastic Stack. So logging, Elastic, we'll just drop it in there. We had, what we didn't show in this, which exists in Mara, is Mara deploys via Jenkins. Every time we make a change, we deploy it to all the platforms we support to make sure it still stands up. That's my fault. I knew Jenkins, so that's the technology I picked. And then, OpenTelemetry, none of us had a lot of experience with, so we went to the OTEL, we went to the observability, OpenTelemetry. We'll try and put this in. So a lot of the things we picked were based on experience with, and then beyond that, personal preference and what we knew we could work with. And again, this is another place where, as we started, talking about this and having people ask us questions about why don't you use X or why don't you use Y, these are the things that we start putting in. So, the Sumo integration came out of one of those discussions. Like, hey, I see you guys are using this tooling. Do you know that we have this tooling that solves all of these problems? So we said, great, how do we put this in? They sent us a Helm chart, and you've seen the result of that. So a couple different things, but basically it comes down to personal preference. And again, if you think we made the wrong decision, and trust me, many people do, raise an issue, mention, say, I see you have X, I'd like to see Y, and we'll have a discussion about it.
Yeah. I guess I'll answer stuff on the OTEL side as far as I think the question about why choose the components you choose. We at Sumo have been doing a lot of upstream contributions to OpenTelemetry project, specifically when it comes to Java instrumentation is the latest one that everyone keeps talking about right now. And it really has to do with as far as which components and which libraries and which different things that we're working on, it has to do with the stuff that I kind of touched on the how to contribute slide, which is just a lot of different things from the community. If we get a lot of community requests for something like, hey, can you create a specific module for a specific, end result that I want? And then we'll probably talk about it internally and see, what resources can be put toward that. Because it's really important to put a lot of sweat equity back into these open source projects, even for companies like Sumo. Because as people sort of the hot topic right now would be also with respect to Java, getting instrumentation to work. So being able to collect all of that data and put it through something like Sumo. So I know there's also, as far as which components to work on, if we're seeing a lot of community interest in something, we might start working more on also auto instrumentation for those particular, for a particular component or a particular library, or particular technology. And I mean, we might also even get like people saying, hey, we want a specific feature request, a specific like help wanted tag, and you just kind of like organize all the different feature requests. If you see a lot of the same feature request, suddenly it becomes, it's like, oh wow, a lot of people really care about what happens with, you know, this particular library or this particular technology. And then we just end up working on those particular components.
Perfect. Thank you, Melissa, for answering that as well. It does look like that's all the time we have for today, but I do want to give a big thank you again to our wonderful presenters, Jason and Melissa, for being with us today, and a big thank you to the audience for attending today's webcast. Again, this webcast is sponsored by Sumo Logic and NGINX and presented by Redmond Mag and Visual Studio Magazine. Have a wonderful rest of your day, everyone.
Thank you.
Thanks.